There is none as far as I know.
All right.
Thank you. There's still a door open.
Okay, we're about to start. Please file in and close the doors. Come on in, everybody. Plenty of room.
There are seats towards the front.
Okay, hi, I'm Barry Leba with Huawei. If you were at the plenary last night, you heard Yi Zhao tell you how pleased we were to be hosting this meeting and sponsoring the hackathon throughout the year. We're also pleased to present a technical topic for the lunch speaker series today. So we have Andy Malice, whom many of you know, most of you perhaps know. I served with him on the IAB back in 2008, something like that. Andy's a distinguished engineer at Huawei and specializes in product and network architecture and future evolution, standards leadership, customer consultation, and a number of protocols, mostly in the routing area. He used to be at Verizon, Tel Labs, Cascade Communications, and BBN. He's been around. So I'm going to skip a lot of the rest of the bio here and just say that Andy's going to talk about building end-to-end service experience assured network.
Okay.
Andy.
Hello, everybody. I'm Andy. Can you all hear me okay in the back? Okay, cool. Very good. So anyway, this right here is an outline of the talk. Basically, what I want to talk to you about is an outline of the problem space, requirements and challenges that we're seeing from new applications on the internet, current work to address these requirements, both here at the IETF and elsewhere in other SDOs as well. What other work may be needed, proposals for the future. And I do have a spoiler alert here. I don't plan to come with any prepackaged solutions to basically cram down your throats. What I'm here for is really to provide you all with some food for thought and hopefully further discussion down the line and perhaps the formation of some new work here in the IETF and elsewhere. So with that, let's get going. You know, the internet, of course, has been a huge success, and it's IPv4, V6 are the narrow waist of the internet, and they support countless applications, as we know. You know, there's some people who try to make the argument that HTTP is the new narrow waist, but there's still a lot of applications. In fact, the majority of applications that don't run over HTTP or in a browser, they really do run straight over IP and then either UDP or TCP and so on. However, today's internet, especially what we think of as the public best effort internet, does have a number of challenges that still need to be addressed. In fact, most notably, a lack of widely available end-to-end service guarantees for things like latency, jitter, and packet loss. And this really limits the some applications that people would like to be able to bring onto the internet. And I'll be talking about the requirements for those going forward. And the focus of this talk is really to talk about what we can do with the wide area multi-domain open internet. You know, I really don't want to talk about private campus and data center networks or very well managed single domain traffic engineered networks, because those all basically run pretty well, but they're for limited applications. And, you know, it's not really what we really deal with here, which is the public internet. So here are a few of the architectural, just before I move off this slide, there was one example that I just wanted to talk to, which is, you know, just talking from personal experience. I've got pretty good internet service at home. You know, I've got Fios from Verizon, which is a GPON-based service. I've got 75 megabits Symmetra coming into my house, but even still, You know, if I'm streaming video off the net, there can be times when the video playback exceeds the local buffering that I received off the net, and I start seeing the twirling. You know, and I'm sure this is something that you're all very familiar with too. And so, you know, even with the great service I've got coming into my house, still somewhere along the line, there are barriers to it being as good as it could be. So just with that, you know, here are some of the architectural issues that really prevent end-to-end internet service guarantees. Well, you know, some of them are coordination across multiple layers. And I'm going to be talking more about this. This is kind of like a preview of a lot of the things that I'll be talking about today. You know, there are a lot of point solutions that people are talking about at the various layers, and the link layer, and the network layer, and the upper layers, and then the control planes. But very often, there isn't a whole lot of coordination going on between all the different point solutions. And so what you might see is, you know, things aren't quite as optimal as they could be in terms of what people are working on and what they could be working on in the future, especially with regards to various SDOs. And by SDOs, I mean, you know, the IETF and a lot of our sister standards development organizations, such as the Broadband Forum, IEEE, and, you know, 3G MSM, and, you know, 3GPP, and so on and so forth. And so each is basically looking at their own slice of the puzzle, and they're saying, okay, what can we do to improve things, for example, from the broadband forum, in access networks? For 3GPP, what can we do to improve things in mobile networks? In IEEE, what can we do to improve things at the, you know, at the Ethernet layer? But in some cases, there isn't a whole lot of coordination going on. And it's difficult to have end-to-end interoperable solutions as a result. And, you know, there certainly is a mechanism for cross-STO cooperation, which is liaisons. However, you know, liaisons often don't work very effectively when you have a very complicated problem set. You know, you need some more concentrated thinking and you know, and cooperation than just passing liaisons back and forth to each other. And then there are things going on in the service providers as well. And I come from a service provider background. I was with Verizon for a number of years before joining Huawei, for example. So I've certainly got a lot of experience here. There's very inconsistent implementation of a lot of the work we've already done. You know, DiskServe is what, 15 years old now, if not longer than that. 20 years old, and then we have DiskServe TE, which goes back to like 2005 or so. But you don't see a whole lot of, you see a lot of implementation of it in private networks and in well-managed enterprise service networks, but you really don't see a lot of it end-to-end in the public internet. And in the public internet, you also see there's an inability for the service providers to aggregate like flows together. So like flows can have similar treatment to the backbone. Now, in the public internet, it's really impossible to do flow-by-flow treatment of each individual flow of the network, because you just can't scale. And if you know, if there's one thing we have to do in the internet, it's scale. But aggregation works very well when it comes to scaling. So if you can effectively aggregate, for example, all low latency traffic together and put that through a particular path through the network, then that may do better than what we're doing now, which is basically nothing at all. And even if these things do get implemented by one particular service provider in their AS, very often you don't see it in the next AS along the path, because very few of us are in the same AS as all the servers that we go to throughout the internet, right? Certainly when we're here in Korea, we're in a very different AS locally than all the servers are that we normally talk to back home, and so on. And there's a whole lot of lack of coordination across AS boundaries. Very often across AS boundaries, what you have is you actually have a layer 2 link. You have like 100 gig link between service providers, which is, fine in terms of bandwidth, but other than that, you lose a whole lot at the IP layer for the treatment of the packets. So there are a whole lot of new things coming down the line too that we want to pay attention to in terms of the requirements on the internet. And one of the big ones is 5G and network slicing. And we had a 2-hour meeting here at the IETF about this on Tuesday night. And so I can't encapsulate in 2 minutes what we covered in 2 hours on Tuesday night. But I just have a couple of slides that give you a very big overview for those of you who weren't here Tuesday night. But I really encourage you to take a look at the slides that were presented in that side meeting with regards to 5G slicing if you're really interested in the topic. So anyway, so some of the challenges is if you take a look at the chart, that's from the NGMN 5G white paper. That's the source for this chart. It's talking about a whole lot of different applications that the folks who are designing 5G want to be able to run over mobile networks, the 5G mobile networks, and it talks about the requirements in terms of user experience data rates, which are easy enough to meet perhaps, but what's very hard is what you see in red, which is the end-to-end latency that they need to see in order for these particular applications to work. In some cases you have latencies under 1 millisecond in order for a particular application to work over 5G, and this is what the mobile folks are aiming towards. So then the other thing they're working towards is called network slicing, and there'll be a bit more on the next slide. What the whole point of network slicing is that you can have different applications and different users that actually get their own, what you can think of as a private part of the 5G network, end to end, everything from the radio all the way into the data center. You can think of it as having your own private part of the 5G network that's supposed to be completely unaffected by anything else that anyone else does in the 5G network, and have completely private data on that and so on. And that's a very hard problem as well, because you have to have complete isolation of one user's traffic from another user's traffic while still sharing common resources in the network. So it's a very difficult problem, and that's why we spent 2 hours on Tuesday night talking about it, and that was really just scratching the surface. The folks over in the mobile SDOs, of course, spending a whole lot more time talking about this. And so, as I said, end-to-end latency in particular is a very strong requirement for what's coming up in 5G. So this right here, so the work on 5G slicing is going to really require a whole lot of innovation in the world of quality of service, just because you have to have the guaranteed services for the applications that are going to be running over 5G, and those require complete isolation from each other. And so what I think the mobile folks are finding is that current QoS mechanisms that we have in routers today, for example, and in switches don't always meet the requirements that they're coming up with. So it's going to require a lot of innovation throughout the networking industry, I think, not just from the mobile space and the radio space, but in the router space, because routers make up the backbone of mobile networks, as we all know. If you're doing mobile front haul, mobile back haul, that's all implemented on routers, right? So that's going to require a lot of innovation in the router space in order to be able to implement the requirements coming out of 5G. Now, some other applications that we're seeing that people would like to be able to use is, a lot of people are into multiplayer gaming over the net, and the next extension of that is going to be, virtual reality-based experiences, whether it's single person or multi-person virtual reality and augmented reality. And there are some very definite latency requirements that come out of being able to use virtual reality and augmented reality through the internet. Now, in some cases, you have to worry about the actual speed of light delay between the user and the server, because if you exceed about 20 milliseconds of delay for virtual reality or augmented reality, you start getting a disconnect between a person's movements and what they're seeing with their eyes, which leads to some extreme vertigo, which you want to avoid, certainly, or else it becomes a very unpleasant experience for the user. So in a lot of cases, this is going to require not only thinking about what we can do about latency, but also some intelligent work towards what's the right place, what's the right placement for the servers, for the service, and routing the user's packets to the proper server so that they get the proper latency that they need. So in cases like this, you could imagine a whole set of distributed servers. And then a part of the puzzle is not only what we can do in the network to reduce the latency between the users and the servers, but also making sure that we route the users to the proper servers as well. And of course, another part of the puzzle is bandwidth as well, because you want to make sure that you have enough bandwidth that's basically guaranteed to the service so that the user gets excellent quality of service in their headset, basically 4K video. Then we have other applications that are coming online that people would like to be able to basically bring into the wide area, whether it's remote healthcare, that's becoming very important. And in some cases, people are already attempting this, but they're really not doing it over the public internet. They're doing it over leased line circuits, for example, just because you really, at this point in time, can't trust doing things like remote surgery over the public internet, right? But in the future, if we could harden the public internet to the point where you could guarantee the service to the medical provider, such that they could use the same the same internet pipe they've come into their office for this, as well as for just their record keeping and so on, and regular internet access, that would be a big boon to them. It would certainly cut down on their costs, and that would be a big win. Factory automation, that's something that's being done an awful lot. Right now, it's being done with specialized networks, again, because you need to guarantee the latency to make sure that the machines get the feedback that they need at the time that they need it. And if you want to be able to bring this to the wide area, so you could, for example, coordinate what's going on between a number of factories, then of course you may have to be able to guarantee the latency requirements that are required there. And finally, of course, smart grid is another thing that people are talking about. And in there, of course, there are latency requirements that are that have to do with the phasing of the electrical power, to make sure that it's being generated correctly. And you want to make sure, if you have feedback loops, such that you want to make sure that the power goes to the right place in the smart grid, depending on demand, that the feedback gets there at the time that it's needed. So, there are all kinds of emerging applications, and this is just, touching on a whole set of applications that could really benefit from, coming on the internet, if it could provide the, the loss management and the latency management that they require. Now, this is not the first time, of course, that people have been looking into this problem. In 2013, ISOC, the Internet Society, held a workshop on latency. And at the time, this was 3 years ago, so at that time, they basically held a reducing internet latency workshop. And what they found are a taxonomy for the major sources of latency in the internet. Basically, there's processing delay, computational translation, forwarding, encapsulation, decapsulation, NAT, encryption, compression, error coding, and so on. Then you have multiplexing, delays needed to support sharing, shared channel acquisition, output queuing, and so on. And then you have grouping, which is reduced frequency of control information and processing, and packetization, message aggregation. And then the workshop report is online, and you're certainly free to check it out anytime you like. And by the way, so you don't have to write down stuff like this, we're going to be making these slides available. They're not yet online, but we will be putting them online as part of the IETF proceedings. So you'll just be able to go to the proceedings page and be able to get access to the talks. You can get all the links and everything else. So anyway, so the workshop's report concluded basically that there are fundamental limits, this was in 2013, to the extent to which latency can be reduced in the internet. There's also considerable capacity for improvement, and it's the capacity for improvement that I'd like to talk about. Throughout the system, making the internet latency a multifaceted challenge, and it certainly is, but as it says, there's capacity for improvement, and that's what we're going to be looking at. Then they also said how to standardize the definition of access network latency. Such a latency can be used like bandwidth as a unit of commerce turns out to be a hard problem. And that's something actually that the Broadband Forum is looking at now, and I'll be talking about that in a moment. So what's changed since the report in 2013? Well, there's a whole lot of point solutions going on, and I'll be talking a lot about those point solutions. Low latency is so crucial that now we're finding that content as a whole is much more distributed than even it was 3 years ago. Now we have, CDNs. We have service providers like Verizon who are taking all of their video content and they're putting it into their access network very close to their customer, and so on and so forth. Basically, the service providers who provide the content are moving the content as close to the customer as possible. And that's especially true in things like multi-user gaming, where you need low latency, and other applications where you basically want to be able to provide some amount of bandwidth for the content, or quality of service for the content that's coming to the user, so that the user has a good experience as they consume the content. And so there are management systems which need access and visibility to network latency characteristics, so they can really intelligently place the flows going through the network so that the best server is utilized for each individual user. And then, but of course, this is much easier with stored content than it is with dynamically rendered content, such as virtual or augmented reality or gaming and so on, although there's been some amount of work, as I said, that's starting with that as well. There's advancements and innovations have been made at various layers in exploring technologies to meet low latency technologies. In the upper layer, there's QUIC. There's the QUIC working group here, which I think is some really innovative work from Google. If you're not really familiar with it, check it out. What they basically said is, they're taking a more systematic view of what are the latencies in bringing up a web page in your browser. And what they did was they said, well, gee, there were a couple components of latency in bringing up a web page. One of them is actually getting the TCP connection open. Another of them is getting security going for HTTPS, right? So they said, well, rather than first getting the TCP connection open with the handshake and then doing the security handshake, let's combine them. And that's QUIC. So basically what they do is they have a new transport protocol which combines the security and transport aspects and runs over UDP. And it's an innovative solution to the problem, but it's a point solution, but it's a nice point solution to one of the problems that people see. Another one is L4S, which is taking a look at TCP and seeing what changes we can make in TCP, but it's really aimed at a particular point solution, and it's more aimed at data centers than anything else. So it's not really meant for wide area use. At the network layer, we also have an RFC IP/MPLS hardened pipes. That's really more intended for business service networks, but that's there as well. Latency optimized router design, which is something you don't really standardize, but it's something that certainly a lot of the router vendors are working on. The Broadband Forum's Broadband Assured Services, which I'll have a couple of slides on coming up. Then at the link layer, there's work going on here called DetNet. DetNet really is aimed at deterministic delay rather than particularly low delay. It's making it deterministic. That cuts down on the jitter or change in delay. And it's also meant for particularly constrained environments. It's not meant for use on the wide area internet. There's IEEE 802.1 time-sensitive networking, which is, again, just taking a link layer view of what can be done for time-sensitive applications over Ethernet. Flex Ethernet, which is joint work by the IEEE and the OIF, which is basically taking a TDM-like approach to Ethernet, where you still use Ethernet framing, but in the transport of the Ethernet frames, you actually allocate TDM-like circuits. And so you're able to provide bandwidth guarantees for the Ethernet, but again, this is just an Ethernet layer solution. And then 3GPP, with regards to mobile, has started multiple projects basically related to reducing latency in the radio area networks, in the mobile access core, and in mobile backhaul. And again, but that's really aimed at the mobile solution. With the latest technologies, advancements in packet networks, it's really becoming feasible for us to partition access network resources, to dedicate resources to flows that need deterministic latency, and that's something that we'll be looking a little more closer at as well. And it's really no longer impossible, as we thought 3 years ago, to have solutions to the hard problems of the access network. And that brings me to the work in the Broadband Forum, which is looking specifically at access networks. They have a project ongoing called Broadband Assured Services, or BAS, and we're actually Broadband Assured IP Services, which is being called BAS. And this is in its innovation and area work areas. The whole point of this work is basically that they are also recognizing that there is new requirements for dynamic high-speed on-demand services for broadband access network customers. In their cases, some of the applications that they've been paying a lot of attention to are interactive video conferencing, interactive gaming on new platforms, high-quality 4K and 8K content delivery, 5G mobile, secure vertical market applications such as finance, healthcare, which we already talked about, and the government. They're also looking at the emergence of particular technologies for use in access networks, such as SDN, G.fast, which is a particular type of copper and fiber-based really fast DSL is what you can think of it as, and GPON, which is the next generation of passive optical networking, mobile 4G and 5G solutions for use for broadband access, and other new access technologies that bring down infrastructure costs for access network providers, and also enable new service offerings. And they also have, in the BBF, there's really a lot of service provider participation. They've got very strong access network service provider support and participation in this work, and also from their customers as well, for supporting the new services and applications over and above their current IP service offerings. So the BBF is exploring on-demand, performance-assured IP services, with cloud services, data center interconnect, and fixed and mobile convergence being their initial focus for the work, and then getting into a lot of the other applications as well. So the scope of the work is actually quite large. They've got a lot of work ongoing. They're looking at use cases, which they call scenarios, the terminology, requirements, and architecture. So they have a number of use case scenarios that they're looking at. End user assured cloud service delivery, a data center interconnect, as I said before, a converged hybrid wireline and wireless access for customers, Internet of Things, secure access, teleconferencing, assured mobile services at Wi-Fi hotspots, and so on. And The scope includes a terminology and overall architecture for the system, use cases and requirements, information and data models, management models, the service definitions and performance objectives, and business and marketing documents, and so on. And I think really the thing that we should be paying most attention to, I think, and most important for our use is going to be what they do with their information and data modeling, and to make sure that's in conformance with work that we're doing here, especially with Yang, because as we know, there's already a lot of Yang coordination going on throughout the industry. We want to make sure that this gets included with the Yang coordination that's going on both here at the IETF and throughout the networking industry, and also the service definitions and performance objectives, because what they decide are important in terms of the performance objectives, and the service definitions have to feed back into the work that we do here. Out of scope is changes to underlying technology owned by another STO, and that includes us. So if there's something that they need to be done in the IP layer, well, they'll be coming to us to work with us on it. So if changes are necessary, they'll partner with other STOs, such as the IETF, and they expect IEEE as well, is required to jointly improve the technology. So there's also Flex Ethernet. Flex Ethernet I talked about a bit before. Basically, this was a joint project between OIF and IEEE to give TDM reliability and performance guarantees to Ethernet traffic. But again, as I said, it's a point solution. The IETF also has work. I already talked about the work that was done in L4S, which is looking at queuing delay and latency, but it's really, as I said before, a point solution. Quick I talked about already, and DetNet I already talked about as well. But you know, it's important just to recognize that we already have work ongoing in the IETF, and so we want to make sure that that continues. Now, what we are really seeing as a result of this is we're seeing a lot of point solutions in multiple STOs, from the link layer with Flex Ethernet into connections with a Flexi end-to-end channel, MPLS-based thin slicing, and adaptive queue management, DetNet, working up through the network layer into 5G network slicing, L4S, and then in the application layer with things like Quick and so on. But what we really want to see is something more of a system level thinking about the problem. You know, we have point solutions, but I think what's more important than just point solutions is starting to look at an overall system approach to latency. You know, what we can do to think about this as an end-to-end problem, not just as a series of point solutions that are being done in various places. So we've been doing some thinking about this inside Huawei, and what we're doing is a bit of experimentation that we're calling SEAN for now, a Service Experience Assured Network. What we're trying to aim forward to in particular environments is ultra low latency and jitter, zero packet loss, constant bandwidth assurance, and on-demand zero-wait deployment. And we're basically doing that by taking, you know, a more cross-layer approach to the problem and looking at, okay, what are the problems in each of the layers and what can we do at each of the layers? So for example, for service deployment, looking at, for example, SCN-based solutions as a possibility to manage end-to-end service and end-to-end signaling across various network domains via protocol extensions. And then what can we do within a particular network, such as network resource allocation and reservation for particular large flows, algorithms for network resource and delay planning, and then within a single router, what can you do there? You can do ultra low latency forwarding architecture and routers, optimizing packet processing, for example, improving your traffic management capabilities for low latency and zero packet loss, and efficient service classification within the routers. And then at layer 1 and 2, we can make use of Flex Ethernet to interconnect the routers, optimized Wi-Fi and next generation low latency access technologies. Now this right here is a demo that we're working on putting together based on virtual reality, and we didn't get it done in time for Bits and Bytes tonight. So Bits and Bytes tonight is going to be focused on SFC, but we hope to bring this in for the next Bits and Bytes. So in Chicago, we're hoping that we'll be able to bring this in and show this to you. It's basically going to be a VR service, and we'll have traffic generators, so to create congestion in the network and show that the VR and AR still continue to work. So where do we go from here? This is my last slide. Basically, what we'd like to do is further development of new technologies and achieve low latency end-to-end and loss over a wide area of packet networks to enable more latency sensitive applications, to better utilize the technologies we already have, and to do more system level thinking for technologies that we don't yet have, for work being done both here and other SDOs as well. So, one of the possible things that occurred to us is a workshop where people can just get together for a couple of days, talk about their own aspects of it from their particular point of view, and see what we can do about some system level thinking end to end to have more effective solutions than just the point solutions that we've been talking about so far. We really want to focus on cross-layer interactions and system-level issues, perhaps leading to new standardization here or elsewhere based on the results. To answer basically the questions that you see here, are there advantages to be gained from taking a broader view of the different technologies at the different layers and what their interactions are? What are the effective interactions and coordinations between upper and lower layers, such that we can make effective optimization of latency and loss sensitive services? And given the larger issues that prevent end-to-end service guarantees, where can we most intelligently attack the problem to get the biggest bang for our buck? So with that, I'd like to know if you have any questions. The microphones are open. And please say who you are. Okay.
Henning Schultzwenny. One of the sections, very interesting presentation. One of the sections that would be missing if it were an internet draft is the security considerations.
Absolutely, yes.
So anytime, and obviously the topic of quality of service is not a new one, as you well know, and we seem to be recycling it every 5 to 10 years. And one of the reasons that I think previous efforts have not been quite successful, there are many, and this is not an easy problem or not a single failure problem, has been that you can imagine that you will have to worry about prioritized denial of service attacks. If I manage to get access to that priority setting, I will obviously abuse it, which means I will probably have to charge extra for that service so that I don't abuse it either deliberately or just because I'm greedy. And which now means that if I have that service as a consumer, if one of my application goes rogue, I not just have a denial of service attack on my link, I also have a denial of service attack on my bank account.
Yes.
And so,
absolutely. Absolutely.
So I wonder if, as part of your Sean exploration, you have, or the broadband forum for that matter, has thought about how you can prevent exactly that, because that will probably stifle one story like that, will probably kind of take people's enjoyment out of a augmented reality.
Yes, absolutely. Especially in the BAS work and the broadband forum, security is absolutely a part of the architectural work that they're doing there. I didn't have a chance to include everything, but absolutely security is a part there. As far as Sean goes, as I said, it's in the early stages, but certainly, absolutely, security is important there as well.
Yeah, because when applications can be compromised, even if they're authorized, they can suddenly, as we know from cameras, which might well be a useful contributor to these type of services, low latency type of services, we know what happens when cameras do their own thing. So
absolutely.
Hi, Andy. David Black. Among other things, Chair of the Transport Area Working Group wanted to give you updates on a couple of things on your radar screen. First of all, Transport Area Working Group talked about L4S. TSVWG is going to be the new home of L4S, so now you know where to find it. Also, you mentioned an obstacle about lack of diff server deployment across ASs. There is a draft on the next IESG telechat agenda that takes the first shot at that problem.
Awesome.
Draft IETF TSVWG diff serve intercon. It's co-authored by a colleague from DT, so it's real.
Okay, thank you for that. I'm gonna have to read it.
Please do. We had a great deal of fun getting it. We had a great deal of fun getting it done, and one of the ways that we got it done was to back off from full generality. It takes a limited approach and says, let's see if we can get a few things to work across domains and do it without disrupting internal operations of the domains. And we think we did something interesting, but I would characterize it as a first shot. Please, please, everybody do read that.
Absolutely, thanks.
Finally, I have a question for you.
Absolutely.
You talked about in the VR and I think some other places, end-to-end reservation. As I'm sure you're aware, traffic aggregation QoS is a headache. Reservation aggregation, by comparison, is a nightmare.
Yes, absolutely.
What have we learned in the past that's going to make it different and actually work this time?
Well,
sure. How much RSVP would you like to buy?
That's what the answer. Absolutely. But really, right. Oh, someone shouted money as
my response to Mike to money was, okay, how much RSVP would you like to buy?
Yes, exactly. To be more serious, reservation is a problem. Absolutely, I agree with you. But there may be other ways to solve it as well. One of the things that the BBF is looking at actually in terms of reservation is looking at applications where you might actually do something like have a web form where you can reserve bandwidth in advance for a particular purpose. Of course, then we have to look at what the protocols behind that are. But that's one of the things that the BBF is talking about, for example.
I would also encourage people thinking about this to step away from the entirely too attractive ETE acronym and start figuring out where the actual problems are and how to solve them. You mentioned particularly that by and large it's the access networks that cause the headaches, not the backbones. If the backbone operators have the backbones and the backbone interconnects under control, maybe, just maybe, an attack on reservation on the access networks of limited domain might get somewhere.
Cool, thanks.
Hello, Marco Hoogwoning. I work for one of the internet registries that's probably less relevant. And I'm certainly not expecting an authoritative answer from you, but I would love to hear your opinion. But
sure.
One of your first slides contained the hourglass model.
Yes.
And then sort of from an architectural point, and the way I sort of see it is like, okay, so we are creating sort of these different slices that 5G calls slices. People have different terminology. Where would you expect that we still be able to sustain that hourglass, or do we get a multi-stem hourglass, or would it be multiple hourglasses sort of glued to the same base? where would we end up architecturally, do you think?
Well, I don't see a whole lot of change coming to the hourglass model, just because that's the way it is. In the future, as I said, people have talked about the hourglass moving up to HTTP, right? And so you can think of it maybe as, rather than an hourglass, you have the top, and then you have HTTP, then you have a widening, and then the narrowing at IP, then it expands again, and it may end up being a model that looks something like that in the future.
So we're just about out of time. Linda, last question. Please make it short.
Okay, I want to make it very short, just to
And you
address. Linda Dunbar from Huawei. So address David Black's question about what has changed. RSVP has been a headache for the past, and this answer on the money. I think that's, I just want to give a few more examples. And nowadays, and you will see, if you just search on internet, like latency monitoring services, there's so many new companies popping up to provide that services. Because why? Because the content managers, content systems, CDNs need that kind of exposure and visibility to the network so that they can distribute their content more intelligently. And as David said, end-to-end, the end-to-end doesn't mean from here to US across the globe. The end-to-end more likely will be like in the access domain or in a shorter, like multiple hops, and then be able to provide that kind of low latency services. That becomes more feasible. Okay.
Okay, thanks. And I'd like to thank you all for coming and enjoy the rest of the IETF.
Everyone, please take your garbage out. And the next thing in this room is one of the 2 BOFs at this IETF, the banana BOF. So you might want to check it out. Thanks. Worked out great.
Hi, good to see you. This is Yong Shui from Tsinghua University. Yeah. So I also wrote to you about the invitation because I'm an editor for the IEEE Internet Security and taking charge of the standard team program. So I know you are very, very famous and expert in the standard. So if you would like to give us an article